Hi, Bogdan. Welcome to the WeChat Tech Podcast.
Hi, Vytas. Thanks for having me.
No worries. Great to have you. Great to have you here. So, look, firstly, let's sort of run through more about yourself, and can you give a short intro about, I guess, who Bogdan is to the audience?
Sure. Bogdan Grigorescu, technology by formation, all-timer in the tech sector, usually the enterprise, very big, large enterprises, um, multinationals, or with global footprint. Um, Few industries moved across. I'm industry agnostic, but I didn't work in every single industry in the world. High tech, industrial robotics for nuclear and the military. That's not on my CV. Um, and that's where I started electronic engineering, hands down transistor level work on boards for robots. And telecoms, consultancy, finance/insurance, advertising, gaming, e-commerce, retail, including online retail of all sorts. But on the tech side. So yes, of course, not every single sector in the world for sure, but
You're not far off. You're
as
not
as
far
a
off.
as DevOps is a topic and DevOps it's industry agnostic, I fit right there. Um, DevOps it's a universal approach and practice and culture to making technology work
Yeah.
in the good way, and it really doesn't. It's not pertaining to one or the other industry, but of course there are rules to follow because of the laws and regulation and the constraints of the place that and DevOps is good to adapt to it.
Yeah. So,
One
look,
of the
Bogdan, we'll
skills.
we'll, we'll dive into so for the audience as well, this podcast is mainly going to be around like sort of automation and sort of the DevOps principles within that, with sort of conversations around how AI and automation has good and bads, and yeah, we're going to have a deep conversation on that front. Before we do, again, it'd be good to sort of deep dive a little bit further into, I guess, how you got into tech, right? So from your perspective, I know you've had sort of a very sort of long, and like you said, you've been through a lot of industries, and you've been doing this for a long time. So I guess what originally sparked your interest in technology?
Um, the curiosity of fixing things. So things, problem of things, not problems you think of it, problems you face. You have a broken table. Why is it broken? How it affects you? Are you gonna fall over, or actually it's not that bad, but it's unstable? And how to fix that instability, or how to fix a breakage? But not just like a table. Anything, even toys. When I was a child, I liked to see see how they actually work, because as Steve Jobs, design is also how it works. It's not just how it feels and what you think about it, but how it actually works. That's design. So I also broke things to see how they work and then try to put them together. That was from childhood. And then it was back in those days, people were, I guess, I guess that's how it feels to me, more practical than today. They're more hands-on in the sense of doing things on their own, even if it didn't come into the formation. Like if, let's say, you're a writer. Well, writers back in my country, back in the day, they were repairing their own cars.
Yeah.
Not everything on the car. No, the most simple stuff, of course, changing the oil and the radiator and things like that. But when it comes to more complex, obviously not. But everybody was doing that. So, like, they're not mechanics, right? So people were more connected to the physical world and do something with it, for good or for worse, than today when it's more abstract than, say, 30, 40 or even more than that ago. And so that was number one, probably the most important. But then it's also a little bit of formal education, because to get your structure and form your thinking, essentially forming your thinking, how you approach things, discovering things that otherwise either you won't, or you'll discover then maybe when you're in your 40s instead of being in the 20s. So I did electronics and telecoms engineering, also because of the practicality of it, thinking, well, communication is the number one most important things that happen between people. And that drives behaviors, that drives what we do, when we do, how we do, why we do, and how we live our life. It's one of the big drivers, how we communicate. That's why we can talk and we can write, hopefully all of us. Um, and if you look in an organization of any kind, if you have really good insights in how the communication works inside, you will know what the structure is without looking at documents, just looking at how they communicate for a while. What kind of organization that is, what kind of culture, what's the dynamics, and is it more hierarchical, is it more horizontal, is it more matrix style or not, or it's a mixture of, like, you really get all these things by looking at the way they communicate for a while, for a period of time. You don't have much documents necessarily. That's obviously is good to read the documents, because that's also a form of communication, how they write stuff. But yeah, communication and so the practicality and the communication aspect, again, that's why I went into telecoms, and telecoms, it's all about electronics, and electronics, it's all about automation. In case people are not aware, automated system always have at least one feedback loop. They cannot exist without that. And that comes from electronics, actually. Probably I've been unfair. I think mechanics had that too. But, since the days of the first tubes, if you look, even an electronic component has two legs, at least, or three. That's a feedback loop right there. It can't work otherwise. And that's a core principle of automation. That's what we have in DevOps as well, with any kind of pipeline, which is a form of automation, integrated. You have input, output, but you also have feedback loop out of that output back into the input. The reason for that is the stability of the whole circuit, which otherwise gets unstable and frankly explodes. It happens with bridges and, breathing, it's a feedback loop as well. You breathe in, breathe out, or you die. That's really is the whole life, I guess. It's hinged on feedback loop. So electronics has that hands-on down to the component level. The way circuits work, the way the components actually built, it's all centered on these feedback loops and the stability of the circuit, and then obviously the throughput and the performance and the consumption, and does it make sense even to have it. So that's how I got into technology. And then I got my first job in telecoms, big orgs, what is now called Orange. But I also work for the government, you would say, in the telecoms area, big digital switches in the day, and telephony networks, wired. Wi-Fi didn't existed yet. It was in labs. The concept existed, but not commercially available. Internet was with modems, like not even 56K modems. We're talking 19K, 19.2K modems, and teletypes and all, but it worked for that period of time.
How did you find the transition, Bogdan, from the telecommunications to, I mean, that like is it's obviously the common sort of route to go, like down the networking, and then I guess through to the automation, because again, like you said, it is very much automated. So how did you find that transition as you've sort of progressed, right, from the networking to now, say, the DevOps, automation, and all the sort of good stuff that you do now? How did you find that transition from sort of early stage, I guess?
The most valuable things about networks I found out by playing games. Back in the day, playing games in a network was new. But it was of high interest to everybody because, of course, you don't have to be on the same console to play the game, right? So that's advantage number one. You also don't have to be in the same room even. You can be in the same room, 2 meters, 3, 5, 4 meters apart, but you can be in different places around the building, around the city, or even in the world. Obviously, the limitation was the speed of the network and the quality of the network, but for simple games that worked. But you're in the same building, then you're on the same LAN. And therefore you got the speed, you got the low latency, and it was just working, right? But you have to be networked together. And the games start allowing that. They were designed to be played in the network, but not all of them. It was still new. But how to make it work? You have some tutorial, it never really worked from the first attempt, never. So you had to start understanding TCP/IP and port forwarding and blocking ports and, two-way TCP/IP allow, not just one way, and broadcasting and multicast. And like, you really start going into that if you wanted to play. You tend to, or you can pay somebody to make it work, but that was not really an option, right? Who the heck is gonna come and fix your play at home? Nobody, or at work, nobody. And so I learned the most valuable skills I learned about networking was by playing games, essentially, or making them play into networks and for other people too. Then, of course, I start applying that at scale in my work. There you had the advantage that you had help. You're not on your own, like in gaming. You have to connect with your peers and they had the same problem. At work, it was much more structured and you had a lot more information. But of course, the problem had a very different impact. Impact was 1,000,000 times higher than playing games. But it was all about the same thing. How data moves around, how data is encoded and decoded and so on. If you miss a packet, is it the end of the day? Sometimes it's not, sometimes it is. If it's voice, it is. If it's not voice, it isn't. So you understand the management of traffic over network and quality of service principles, that voice packets always come first, and then web chat was new, and then email the very last one. Video also come first as well as voice. So then the network is designed differently. So all these key aspects of networking principles that we have today, that's the way I learned them, by doing this. And
I think from already gathered is you're very much a problem solver. Like you very much like I feel like for any processes or tasks that you do, you always ask yourself the same questions, right? I guess that's what a problem solver does. I mean, from yourself, then I guess before we dive in more into the technical stuff, I guess passions outside of technology. What does that look like for you? For being a problem solver, what do you enjoy doing outside of tech?
playing chess a
There you go,
lot.
problem solver.
Playing chess. Also reading a lot. I used to read mostly fiction, but in the last, I would say, way more than 10 years now, I don't think I read anything fiction. Very little, but non-fiction. Wherever it's tech or not, history as well. Geography, how geography shapes history of people, and also the history of technology. I also read about artists. I'm not good at art, but I like art.
Yeah.
I like, building architecture. I'm a fan of that, art deco and all that. Though I'm a total greenhorn. I just enjoyed looking at it in museums and all. It's also very relaxing. But I learned a few things. I learned that actually DevOps is not strictly being an engineer culturally. DevOps, it's about finding the right tools for the job, which means understanding the job, mean understanding very well the problem to solve at hand, which is a big deal. It really is probably the biggest deal of all, understanding the problem to solve, and then not stick to process. not stick to process if there's something better, the better way to do it. So find a better way and the better tools to solve that problem. Given the constraints, of course, it's rarely to be the optimal tool and the optimal approach, but it's the best for the case at hand, for the problem at hand. And that's what DevOps does. DevOps engineer that stick to process, they are not really DevOps engineer. They are automation engineer, and it's not the same thing.
Yeah.
And so if you look in the history, Michelangelo was a DevOps engineer. You say, oh, but he was a painter and sculptor. Yes, but let's look what he did. And that's very important to understand for every engineers of today to see that DevOps, it goes way before, way above engineering, is Michelangelo actually devised his own tools to paint the Sistine Chapel. At the Sistine Chapel in the 16th century, which is one of the marvels of the world that he painted, he had to paint the ceiling, but the ceiling is, many meters above. That's very difficult to reach. And it's not just to reach, but he has to be there for hours on end painting. How? You can't stay straight and paint because you don't have the reach. So he devised this process of being horizontal. But being horizontal, you have to be up really close to the ceiling because you're on your back.
Mm.
And you have to have different brushes. He also looked at colors because he had a different perspective when you're like that, right? You see different. Little better, I would say, because your angle of view is better. So he understood all these things that are going way beyond painting and artistry, right? It is really hardcore engineering right there, and not just one discipline. And he devised a sort of scaffolding by looking at builders and masons and design and build his own one that allowed him a comfortable enough position to be there for even 8 hours a day sometimes to paint. So he iterated, right? He wouldn't get that right from the first attempt or the second. He probably had a number of iterations and, failures, and then he got there. So he built his own tools for the problem at hand that he understood very well. Totally new process, because the way you do things also shape the process, and obviously the process shape the way you do things. It's a feedback loop. So he did all that. He was a DevOps engineer. DevOps engineer.
You know what? I think it's so transferable, right? I think you like it again. It's also like it's I guess it's what you define DevOps to be as, and it's very much. I mean, I think we've got the same perceptions. Like we say, it is a culture, and it's very much like how you sort of, I guess, process information in that sense. And again, it's so transferable. It could be said, like you were saying, an artist can be a DevOps engineer if you look at, I guess, what they're doing to get there. And it is very, very true. And we'll definitely cover more about, like, I guess, the DevOps side of things in a moment. But I think the main thing from I guess the conversation that we had before, I mean, you're very passionate about automation, right? So automation is obviously like a very key part of what you do on a day-to-day basis. So I'd like to discuss more about that, and I guess discuss more about automation done right against automation sort of done wrong. And I know you're very passionate about that. I know you even before when we spoke, you've got I guess thoughts on how a lot of people do automation wrong. So firstly, let's discuss maybe more about what you would define as, I guess, bad automation. And what does that usually look like in your eyes, would you say?
Bad automation, it's a personal take, right? So, nobody has to agree with what I'm saying.
Yeah, of course.
That's a DevOps way as well, by the
Exactly.
way, with an open mind. Sharing experience, it's really part of the core of the DevOps practice, is sharing information. Is nobody goes and does stuff by themselves only. There's a time for that, for sure, of course, but it's all about sharing and getting the practice better all the time, getting this continuous improvement. So nobody has to agree with what I'm saying. You just have to take that into account. I'd be happy. Is not looking at the process, whatever the process is, end to end, where it actually is supposed to start and where it's supposed to end, and what's in between. And the moment that's not done, and in so many cases is not done for various reasons, but is not done, that automation cannot be good. It never is, because of the laws of physics. And so one example is in the early 2000s, a primitive form of automation that could have been very effective was auto replies on email. Web email was new and was getting a lot of traction, and people start, exchanging a lot of email messages, and people were unavailable sometimes on holiday meetings and so on, or, unavailable for a couple of days. So how do we notify the guys that message us on email that we are not available, and also tell them when we are back? Auto reply, right? Well, what's the problem with that? Well, the problem with that is that nobody thought the process end to end. You say, so you, Vytas, have an auto reply, but I will also have an auto reply. So you're on holiday for 10 days. 3 days after I email you, I also am unavailable for 3 days because I'm at a conference. So I send you the email just before I go to the conference. You have the bot sending me an auto reply, or the email server actually is not even a bot. And then my email server replies with an auto reply to your auto reply. And at scale of millions and millions and millions of people around the world, you get this auto reply war. Unnecessary traffic, totally unnecessary, a waste. Yeah. Clogged inboxes, then junk will start filtering some of them. It's a mess. Is that the automation fault? No, it's not. The automation is doing what is supposed to do. But the process was not sought end to end. What could actually happen? Where does it start and where does it end? No, it was piecemeal. So the moment you think about, things piecemeal, automation not going to be affected. It's actually a liability. It's better not to automate than to automate, because you build a problem. You actually create a problem. And it's not a problem that it's easy to solve. So that's that. Another example, also in the early 2000s, the marketer says, we are sending 100 emails a day manually to our seats to reach out people for penetration. And we get, let's say 10% penetration, 10 out of 100. 10 out of 100, they respond, then we have a lead. Oh, but we can automate now. We can have a template text that is just a copy paste, maybe even through a script, it doesn't matter. And it sends to lists of people. So now all of a sudden, we can reach out 1,000 people, not 100, but 1,000 in a week. And we actually do less work. Oh, so then we can have 100 leads instead of 10. But guess what's happening? What happened? Well, the opposite happened. Actually, it went less than 10%, 2 or 3%. So yeah, you still had 20 or 30 instead of 10, but man, you are sending 1,000, not 100. So it was way less efficient and effective. And then gradually it even went less than 10. They start having even less traction than before, even though they're sending 10 times the volume in the same time. Why? Well, because people got fed up. People got fed up because not just one marketer did it, all of them. So now people start being bombarded with marketing emails all of a sudden in a short time, and the email was getting clogged. There's so much noise, they couldn't differentiate from emails that were important and marketing emails. Flooded. So people didn't pay attention, straight in junk, so you had start getting near zero traction, from 10% to near zero. But we're sending 10 times the volume. Again, not thinking the process end to end and not understanding how people work and so on, but what it means for people.
I think it's very much what you say, but it sounds like it's like it's over engineering, trying to overcomplicate a matter. And I guess with automation, I think everyone thinks that you can get more out of something when you can't, I guess. And it's one of them things, I guess, where you have to look at, is it worth automating, right? So I guess my next question would be to you, I guess, is through like tech wise, from your experience. I mean, I know you've been through quite a few industries, like you said, and you've been in this space for a long time. Have you seen much of where, I guess, you've seen organizations just automate things just for the sake of automating it? Um, like, what have you sort of experienced in your, I guess, your sort of, your work that you've been doing in throughout your career? Have you experienced any of that?
Not automation for the sake of it, because automating is not cheap at the beginning, so that's why you really have to commit capital to it, human capital, cash, and so on. So not for the sake of it, but because of lack of understanding.
Mm.
So again, they didn't understand enough or well enough the problem to solve. They didn't define it well enough, and therefore they were solving for the wrong problem. Really, that they were solving for the problem they didn't have, but they think they did. And therefore, for what they had in their mind, yes, automation could have very well been a good solution, but that was not the problem. So not understanding the problem at hand, not understanding automation enough. What are the principles of automation? There are a few core principles that don't change. They are immutable. They don't change. I mean, unless the universe disappears, but otherwise they are really universal from the start of times, which is what? Standardization. If you don't have a standardized technology stack, standardized enough, doesn't have to be perfect. You cannot automate. No matter how much you try, it's not going to work out. Pigs don't fly for a reason. And so, yes, I mean, unless they put in a helicopter or something, then they fly. But yeah, and it's the same with automation. And then you have to understand the feedback loops. And then you have to suppose you have standardized your stack, but what goes in, it has frequent changes. Not a good case to solve with automation at all, because if you have frequent changes, like really frequent changes, that's what I mean, daily, several times a week or several times a month, then you have to change that automation on a very regular, frequent basis. And so that creates friction, delays, and cost money, and not a little, because it may be only 1,000 pounds couple of times a week, but the year has 52 weeks, so that's 104,000 pounds just to change the automation for petty things. So frequent change is not good for automation, non-standardization not good for automation, and also complexity not good for automation. High complexity is never good to automate, simply because you'll have so many edge cases that the exception becomes a rule, and that defies the purpose of automation, right? It defies the purpose of automation. You have too much variety. Therefore, automation not going to work. Instead, you will create your problem. So these are the three core principles. And if you don't check them all, it's not going to work out. It's not like you pick one or three or two or three or a combination. These are fundamental. You have to check them all before you even think of, physically implementing any form of automation.
Nice.
And I've seen that all the time, failures on this front. And then automation was blamed. Automation doesn't work. It was not supposed to. It was not. It's good that it doesn't work,
Yeah.
because that's the way of the world. And if you think it does work, that means you are not looking where you should be looking, which is even worse. It's a false negative. I don't have the problem. Yeah, because you're not looking in the right place, but that problem is actually very real and costs you money.
Yeah, for sure. I think again, I think moving on from this a little bit onto like I mean, we discussed, I guess there's quite a lot of crossovers as well within this automation conversations, but I think we discussed parts of like building processes within automation is obviously a very big part. So I guess for what mindset, I think obviously you've been in tech now for a long time again, like I mentioned, and obviously you've been in I guess quite senior positions in that front. So what mindset do you think leaders should adopt when shaping like scalable processes? What's the mindset that they should sort of think, you know, this is the best approach to take?
Most times they think about cutting costs. Wrong, in my opinion, because cutting costs is not the same as being more efficient. Cutting costs is like I'm fat. I'm eating 3,000 calories a day and I should be eating 2,000. So let's cut a third of my body, because you know, by the logic of it, 1/3 less, we're gonna consume 1/3 less, right? So I'm just gonna cut my hand from here and from the elbow, and therefore my body is 1/3 less, or about. Therefore, I'm gonna eat only 2,000 calories. Silly, right? And stupid. But that's what it is. So cutting costs should only be done when there's no other alternative. It's an existential. And that can happen, of course. It's always on the table. It should never be anywhere other than the last thought and the last option. When you're facing the wall, then that's different. But other than that, you should think how things made more effective and more impactful, and of course not being wasteful on resources. Obviously, the Kanban style of things, and you know, the continuous improvement and so on. That's the mindset, and that means you're thinking of doing the right thing. Is a very different paradigm. You're thinking to invest and not thinking to cut. Because cutting never create efficiencies. Never
Yeah.
did and never will.
I think it's a very fine line, right? I guess within processes, because I think it's like again, it's when we spoke before, you sort of mentioning like you know, not becoming a slave to process, right? And that is, I guess it's again, it's like I feel like I guess moving on to that is like, how would you recognize when a process becomes, I guess, outdated or too rigid? Um, from your side of things.
Excel spreadsheets that define the work. This is one of the top signs of the being slave of the process. Tick boxes, that's another one. You have tick boxes or else it doesn't happen. Again, slave of the process. I faced, you know, numerous times, because I work a lot with security, and we have to go live. Obviously, you need security sign-offs that you're doing the right thing and things are secure and ISO 27001 and so on. And they are coming with Excel spreadsheet in the region of 100 tick boxes, because in the large organization, right? So they had like a template for everything, and you have to tick them all. Obviously, it's not possible, because like the heck, you're not changing the whole work from top to bottom, right? It's one part or the other, and you have a design and an architecture, and you explain it, and they ask questions, you answer, and if you don't have an answer, you're gonna go back to the drawing table and address them and come back. So yeah, look at that, and usually it was more or less half. So 40, 50, maybe 60 that were applying, and we're ticking. But the rest to about 100, they're just not applicable in that case. But no, you have to tick them. Again, slave of the process. And say, okay, fair enough. How about you explain me the risk if I don't tick them? Those 40 or 50 out of 100, I don't tick them. But you explain me the risk in technical terms and in business terms. What is the risk if I don't tick them? They couldn't. So there's no risk. If you cannot articulate the risk, then there's no risk. As simple as that. So, but if you think it's a risk, okay, go back, think it through, then we can discuss some more. Then when you can actually put something forward to me that I can understand, oh man, I actually have a gap there. I don't address it. That's okay. I'm okay with that. But otherwise, what do I have to address? Nothing. Okay, slave of process. I say, yeah, but you can't do that. Well, I can and I will, and you can go and sue me, and you can go to the SU. I don't care, because you got to explain. And yeah, we went live and nothing happened, of course, because they couldn't explain the risk. And then the next time, guess what? I didn't have to tick all the 100 boxes because there was no risk in not ticking all the 100. As long as you tick the right boxes, all of them, then it's okay. But if you think that I have all these tick boxes, slave of process, bad things happen.
Nice. I think from that as well, I guess from yourself then, Bogdan, I guess what advice would you give to any teams that I guess feel overwhelmed by their own processes? Like how would you suggest, like what strategies could you suggest to basically keep processes like lean and humane, so people don't feel, I guess, overwhelmed? What advice would you give?
It depends what the process is. If it's demanded by law, that's not that much you can do. You have to get to certain tick boxes, because otherwise it's, well, essentially illegal. Or regulation. That means you're not compliant, and if you're not compliant, you're an enterprise, you're going to be audited on a yearly basis, and you cannot prove compliance, therefore you have a hefty fine. So that's one particular case. Now, how to get compliant? Yeah, there are better ways and worse ways. There are bureaucratic ways and less bureaucratic ways. So you got to find the one that is less bureaucratic, is not that difficult to change when the need be. It's also understood by those working with it, i.e., can you explain it simple enough? And the documentation has to make sense. If you start writing page after page after page, nobody gonna read it. So you have to write the documentation in such a way, even if it's got to be big, you have to structure it in such a way that is easy on the eye, and actually people will read it and use it, because otherwise, again, it's a waste. So that's true. But there are other processes, they just don't belong anymore.
Yeah.
They just don't belong. So it's going back to culture, a culture of, well, essentially the process is there to be changed and to be broken.
Yeah.
But of course, replaced with something better. Again, not being a slave of the process. So whoever is a decision maker and design the process in the end have to think it through that way. Is it introducing a lot of friction? Bad. Don't do it. Is it difficult to use? Bad. Don't do it. Make it somehow to be, if it cannot be that simple and easy to use, the simplest possible. And then explain to people how to use it just enough. And again, document it properly, not overly document it, just right. Easy to find. If somebody wants, I want to know what are our pipelines? What kind of pipelines do we have? Very simple questions, right? If you scratch your head because you don't know when you find this very basic information, there's a problem. And so put it in the right places that can be accessed in secure way and easily, and it's easy to find, and it's easy to read, it's easy to understand. Again, it's not going to be a training course. Of course, documentation is not for training people, it's for reference. So you got to know stuff. So all this is part of the process. You may have the greatest process in the world. If nobody understands it, useless, right?
Yeah, for sure. I think moving on from that as well, I mean, it's very much interlinked, but I guess it'd be good to, because it's very much what we discussed before again, but it's, I guess everyone has a different idea of what DevOps means to them, right? So moving on to that, I guess from your perspective, I guess how do you define DevOps from your perspective? Because it very much interlinks to what you're saying, right? Understanding principles and understanding cultures, like we discussed. So how or what does DevOps look like to you in your eyes?
It's the mindset of being production first, i.e., we're building things, but how they gonna work in real life at big scale, at millions of people, or billions, maybe it depends how it's gonna work out. That's That's what it is. It's a mindset that is obviously practiced. It is not theoretical. It's actually very practical mindset. How things that we build or we intend to build, how they're going to work in the real world, and how do we know they work, or how they work, or do they really work, or do we have the wrong idea? The observability, right? The very core principle of DevOps. What you look at, when you look at, do you understand what's happening from what you look at, i.e. do you have the right metrics or not, and do you have the right data dimensions or not, and do you get that information in at the right time, when it's, i.e. not when it's way too late, like 4 hours after, when it matters. That's what DevOps is.
I think it's very much like you're saying, right? It's very much a culture, right? With how it is. Do you know what? It's funny because, like, look, I've been in the industry obviously on the recruitment front, but around sort of 8 or so years, and I think back then it was very much. I think companies are still very similar now, right? I feel like organizations still treat DevOps as just a job title rather than, um, you know, like we're saying, like a culture and actually helping a company, um, if that's on the automation front or process information or whatever the end goal is, that, what DevOps should be sort of considered as, and be used to support that sort of, I guess, situation. And I still feel like, it's so common where, organizations are still using DevOps just as a title. And it's not great to see. But I think, from that, I guess, do you see that as well? Have you experienced that before from companies where you worked before, to see, like, like companies just don't understand, I guess, what DevOps truly means?
Yeah, for sure. They do talk enough and sometimes a lot about DevOps, but have a they don't get to grips with it. They don't have a
Yeah.
grasp of it, not a real grasp of it. Um, that's for sure. It's also treated as a order taking sort of organization or function, when it's actually not. It's exactly the opposite, because it thinks through and implements better ways of working that just make sense. But yeah, it's ways of working. It's a trait, it's a transferable skill. That's what it is, core. Actually, a set of transferable skills, not one. It's a set, and we can call them DevOps. And in the past, I don't know if there was a name for that. It's just a name of core transferable skills that essentially fall into the same into the same approach and mindset. And we just call it DevOps. Why? Because it is developing, it is building, but it's also building for the real world, not from a lab. Yeah, it starts with a lab and, hundreds, thousands, even more than thousands of iterations to get it right. But really, it's all about making it work in the real world and not in the lab, in a fancy lab, and that's why uh, DevOps, generally speaking, they reject these fancy ideas of, I know, self-replicating spaceships. That was for real. That one, those self-replicating spaceships, was touted by a billionaire recently and made a lot of noise about it. I think Zuk said that we're gonna get with generative AI to have self-replicating spaceships. I might be wrong. Maybe it's not Zuk. I think it's Zuk, but I might be wrong. And then data centers in space. Yeah, it's technically feasible for a small comms room. I know. Every satellite has a comms room. We know that's happening. But the whole satellite has a few tons. A DC has 1,000 times more, tens of thousands of tons, because you're looking at thousands and thousands of racks. And if they are smaller, they're still being, 1,000 ton plus, maybe not 100,000, but 1,000, but not 5 tons. There's a very big differential.
Yeah.
And that hardware has to be shipped back and forth every 4 or 5 years because it becomes obsolete after that. It just doesn't perform. It's a problem. So you have to ship thousands and tens of thousands of servers from Earth down to orbit, 650-kilometer altitude, in 90% gravity right there. And by the way, the chips are not designed to operate in 90% gravity. You'd say, so what? Well, I'll tell you so what. A 3 nanometers chip, latency at nanosecond matters. You get from few nanoseconds to few tenths of nanoseconds, and the whole performance goes to the dogs. That's why it matters. And so it's just nonsense, right? It's nonsense. And DevOps, it's waging war on nonsense. It's very practical. It's very down to earth. It does have dreams. Of course, it's good to have dreams. That's how good ideas get filtered out, passed to all these production first mindset filters, and then get done. Like really run with it, right? The DevOps people own what they built. You built it, you run it. That's what, again, core principle of DevOps. It's not like some sort of professional services that they go, they get it done, you sign it off, we are off. No, you run with it.
Yeah. I think from that as well, I guess, touched on that as well. I guess it's the AI element of things, right? In DevOps. And I guess from your perspective, do you see AI as enhancing DevOps culture, or do you think it's overcomplicating it?
I think it has
'Cause I
nothing
think you
to
can
do.
have both, right? I think it can definitely benefit certain
Yeah,
aspects of it, as long as you don't take it out of perspective. I think it's
AI is a concept that Turing showed that is a falsity for now. Unless we define what a machine is. I mean, universally define a definition that everybody agrees that, okay, this is what a machine is. Then, yes, the question of can machine think is valid, but not before. Well, AI does not define what a machine is, but they're still talking about artificial intelligence, i.e. machine that think. Turing said it straight out in 1915. He's in the first page of the imitation game. He's right there on the first page of the paper. It dismissed the idea as a fallacy because of that. So a machine can be a cooker with zero electronics in it. It's still a machine, and it's called a machine. A car, a computer, a smartphone, a TV, smart or not, I mean, whatever. Whatever is powered by something, electricity or solar panels or petrol or gas, or that could be a tractor is also a machine, right? So what's a machine before we're talking about this? So I think DevOps is not affected as such by that, affected in the way that it's not going to change the principle of DevOps at all. It doesn't go contrary to them either. It just doesn't. It's yet another set of tools that may or may not be used depending on what the problem at hand, and if it's a good fit for solving the problem at hand in a better way, then DevOps will gonna use it, no doubt about it. And we've seen that with, say, test automation. We've seen that a lot with observability. We've seen that with and test automation, let's say, for example, in security, SOC and penetration test and all, right? So definitely it applies and has uses for sure, big uses, but again, for the right case, for the right problem to
I was
solve.
going to say, do you think there is like some risks in that as well? Because obviously from just overall perspectives, I guess it's how much do you trust AI in I guess in the outputs that is given, right? It's not always correct. It is very much where it's a use-based scenario, right? So I guess for like, automation purposes, like, automating workflows, do you see that there's risks involved where you could be sort of, if you're implementing AI into your automation workflows, is there risks? And like, I guess, how do you see that?
Yeah, there is risk, but again, it does goes to how observability is working, and is it working? Because with AI systems, observability works very differently. The principles are the same. They don't change it. They're immutable. but the way to use them and apply them is very different where AI systems are involved, because the output is a probability. And you have to have solid benchmarking everywhere, and you should observe those benchmarks. What's happened with them? Are they breached? Are they about to be breached? Are they comfortable within? But all those benchmarks have relationship with each other. They are not siloed and monolithic. They do have relationship with each other, and those relationships are usually not fixed. It depends of the context and what's happening. So that's the way they should be understood, and they were observed as such. So that means if you look primarily at logs, no, that's not right. That's not good enough. If you look just at, I don't know, API traffic, let's say, or you focus on API traffic, that's also not good. But of course, in some instances, that's where the focus should be, on API traffic. In other instances, logs, because you troubleshoot, and well, troubleshooting means also looking at logs big time. But when it comes to getting a snapshot, what actually is about to happen, logs are not involved. You're not going to look at logs because that takes time. You're going to have a snapshot of the API traffic, yes, but also the tendencies and the patterns. That's why AI, machine learning, helps a lot, because it uncovered patterns much faster, and you don't have to trust them. You just have to dig into. But the thing is, it narrows down from hundreds of possibilities to a handful. A big positive impact, is it? Again, don't take them at face level, just look into it, but it does cut the effort by a factor of sometimes even more than 10.
Yeah, I think we spoke about this as well before our call, but I guess on a general purpose away from tech, there's obviously like we discussed a bit about the risks of AI, and I guess again it's a use case against, right? It's what people are using it for, and I guess maybe there's not enough metrics in place to use AI, I guess, in the wrong areas, right? So I guess like what we discussed before is how people could be using AI for the wrong reasons, I guess, and how it's still assisting you to do certain things, right? So I guess what are your thoughts on that side of things, away from tech, for just the general purpose use of AI? Do you think it's still like, obviously there is use case, people still use it very much on a day-to-day basis, everyone does, but I guess how would they, or how should they go around to restrict the things that maybe shouldn't be used for AI, like the like what we mentioned before when we discussed was like suicide, for instance. Yeah, what are your thoughts on that?
So that's the GPT part of AI,
Mm.
which is a very small fraction of the field
Yeah,
in terms of models and type of models, not usage.
yeah,
um, I mean, yeah, depends on company. What kind of company are you? Who is running your company? Who are your stakeholders that put money into it, and so on. But if you exposed your employees to GPT as part of the company, that is not in the free time, whatever, that's probably wrong, because you can't really build up your risk profile right there. It's just not possible. And if you can't do that, then you don't know where you stand. You don't know where you stand as a company, as simple as that. Although you think you do, what's the worst that could happen? Go to jail? Yes, that's the worst that could happen. Or go bankrupt. That's more probable than going to jail, but and maybe not as severe, but going bankrupt. It's serious enough. And going to court for years and years, wreck your life and so on. As a CEO, as a C-level, that it should be understood. It's a real possibility. And that doesn't mean you have to be afraid of it. You just have to understand, well, do I really have that risk mitigated or not? If you do, great. But how do you do it and how do you maintain that mitigation then, and so on? If you have the solution for that, go ahead and do it, expose it.
Yeah.
If you don't, just don't do it. And then the question becomes, how do I restrict it? That's not actually difficult. That's a red herring. It's not difficult to restrict. And of course, it's not perfect, but the moment you put in the contract with people, if you use it at work, by contract, you are in breach of contract, you'll be gonna be sued, essentially, taken to court. Dismissal, taken to court, and you can end up with a criminal record. Make it clear from the beginning. So it's up to you. So that's a deterrent right there. But you explain to people so they know beforehand. Doesn't come as a surprise, that know why they commit to, and it's their call if they want to commit or not. Being transparent, very important. And also, offer support for people so that they don't do that mistake. Definitely. Training every year, mandatory training, maybe once a year, maybe short trainings every quarter. I don't know, something that is not a friction, but is mandatory for everybody, from the top level to everybody. So it's instilled into the culture of the place. And it's not being mandatory because it's a bureaucratic thing. It's mandatory because there's a real risk at stake that is life impacting. I would say it's a mistake to expose it to the public. You expose your company to the public through a GPT of sorts, whatever that is. I think it's a mistake. The risk simply is too high. But again, it's up for the companies. And definitely in highly regulated environment, that doesn't happen for good reasons, because simply the risk is nobody will underwrite that risk.
Yeah.
Public transportation, insurance, finance, banking, healthcare, and so on, defense, it doesn't happen. Expose it inside to staff, but not across a company. The use cases are much better defined and they typically narrow. They could be high value though, but they're typically narrow and well defined. That definitely cuts down the risk a lot, like hugely. It still has to be approached with care, but yeah, it is doable. You have to think it through from the beginning though, and all the
Sure. Okay. And I think obviously coming towards the end of this, but I guess just in general, I guess I like you're very much in the in the technology world, I guess. So where do you see AI in I don't know, say 5-10 years? What's your sort of idea in that? Where do you see AI in the future for engineering?
GPT is a dead end. It's already hit a wall for almost a year now. So GPT as an architecture is a dead end in my view. Also diffusion for images and videos. It's a dead end. It's just not sustainable financially and by any other means. It just doesn't. And it doesn't improve no matter even if you scale 1,000 times. We have 40, 50, 100 times better models. No, they are not better. They are just making better use of the massive resources, but the better the more efficient they become, the more usage it drives to. So efficiency by itself and scaling or upgrading capacity by itself never solved any problems ever. And I know in networking back in the day, it was the 10 Mbps network, and everybody was congested. We want more. 100 Mbps came about. Within 2 years or about 3 years, people needed more. Then 1 Gbps, then now it's 10 Gbps. You have 10 Gbps LANs, and it's still not enough. That's because just by upgrading capacity, just throwing capacity at, but it's 100 times more efficient. Yes, I agree. But now you have the whole planet Earth using it. The whole planet Earth using it in millions of different ways than before it didn't happen. So complexity goes over the board. Complexity becomes unmanageable. So capacity never on its own never solved the problem, and efficiency on its own never solved the problem. It has to be in combination. So throwing millions of GPUs at it doesn't solve the problem. It doesn't solve the data problem, which now machines for more than a year now create more data than people. And if that happens, then the model will collapse because they train on their own data and they collapse, scientifically proven. So you need non-machine generating data to be way more than machine generating data. That doesn't happen. So that's why I'm saying it's a dead end. Laws of physics, again, it goes against the laws of physics and is gonna disappear. Nobody wins against the laws of physics. Nobody. Unless you're God, but we're not gonna go the God way, right?
Good stuff. And I guess my final question is for you is for someone that is looking to get into, the beginning of their journey, and someone that's trying to get into automation, what's I guess the piece of advice that you would give them in at the beginning of someone's automation journey that they're getting into, as an automation industry?
If it's for tech,
Yeah.
it's for tech, then maybe this comes as a surprise. I hope not, but if it does, be very good at mathematics. Not as a mathematician, not like that brilliant top. No. Just be very solid on mathematics because it's all about mathematics. Automation is applied mathematics. That's what it is. Control theory, which is really the cornerstone of any automated systems, even mechanical, doesn't matter. That's all mathematics. So try to understand that just enough, just the basics of it, but really be very solid on the basics. And if you want more, definitely go for more. But the basics, be very solid on the basics of the mathematics that underpins automation, control theory, feedback loops, these kind of things. Again, not being top of it, just really solid on the basics. It's not that difficult, by the way. And then practice. Find some ways to practice that, like in small scale on your own, even by playing simulators, and network with the people that have the same, the same interests, not the same necessarily the same. We are of the same mind, not necessarily, but they're after the same things and they have the same interests, and therefore they're open to share their experiences and knowledge and interact with those kind of people. It really helps a lot. So team up with people of, doesn't matter age, race, country, doesn't matter, but they're after the same thing and they share the same interests. And they go about in very different ways, which is great, right? That's how you learn. And then you also share your things, and there will be huge progress if you do that. And go into jobs where automation is part of it. It doesn't have to be stated automation engineer necessarily. No, but look through the role itself and maybe talk to some people if you can down there. You see that, actually, it is about automation. It's just not stated up front, but it is about automation. And can I actually do it better? I think I do. Insert yourself in those kind of environments. It can be big environments, it can be really small environments, startup. Again, it matters less. That's what I would say. But definitely be solid on the basics of mathematics for automated system, control theory. Read a little bit about it just to understand the basics and get it, get solid on that, because that's where it all starts and that's where it all ends.
Awesome. Sounds good. And look, the like I mentioned to you, Bogdan, as well. So the way we finish a podcast is so the previous guest asks you a question, and then you ask a question for the next guest. So the question from the last guest was, "What's the most important principle you use to run your life?" So that's the question to you.
Stay in balance.
Okay. How do you do that?
There's no recipe. There isn't a recipe, and it's the most difficult thing in life is to stay in balance. There's nothing else that comes close to that. Um, yeah, regardless of context, it may be a strenuous context full of challenges and nastiness, or it can be a very comfortable life. Apparently, it's so easy to stray off balance, and we've seen that with filthy rich people. They're always unbalanced. Always. Drugs, all these things. It doesn't mean that they're the only ones. No, obviously, poor people also go off balance. Anyone. It's just the billionaires are more striking because they're always in the news. That's the only reason I bring them to attention, because, almost anyone knows about the billionaires. That's why. But the same problems apply to everybody on Earth. So stay in balance, most difficult thing to do, but also most important thing to do in life.
Awesome. And what's your question to the next guest? It could be anything.
My question to the next guest is, can you describe yourself in a few words, no more than 10 words?
Okay. Awesome. Look, Bogdan, it was great to have you on this podcast. And thank you for being here.
Thank you for having me.
Awesome. Thank you.
Bye.